Welcome to our today's session. We are still looking at topic number 1, that is basic electrical quantities, and our subtopic is charge, that is our area of interest. Previously, we have looked at Ohm's law, we have looked at power, and today we are going to look at charge. And by the end of the video, you should be able to look at two learning outcomes. You should be able to define the term charge, and also you should be able to perform calculations involving charge. By the end of the video, you should be in a position to define the term charge and also perform calculations involving charge. Today, you'll bear with me. My voice is not that smooth. I have a flu. I am sorry for that, but I know you're going to get what we shall be learning through the video. So let's look at our learning outcome number 1, that is defining the term charge. And charge is defined as the physical property of a matter that causes it to experience a force when kept in an electric field. Charge is a physical property of a matter that causes it to experience a force when kept in an electric field. Charge can be positive or negative. We can have a positive charge or a negative charge. And charge, its SI unit is coulombs, sorry. The SI unit for charge is coulombs or coulombs, and it's abbreviated as capital C. The SI unit for charge is coulombs and it's abbreviated as capital C. Back in high school, we were able to look at Coulomb's law, and we know that like charges repel while unlike charges attract. If you see on this diagram here, we have a positive charge and a positive charge. Those are like charges. We have a negative charge and a negative charge. And we know that like charges repel. This arrows shows repulsion. Therefore, there is a repulsive force between the positive charge and the positive charge. They cannot attract, they repel each other. Therefore, these charges are experiencing a repulsive force. Now, on the other side, we know that unlike charges attract. So we have a positive charge and a negative charge. These two charges are unlike charges. Therefore, we expect them to attract each other. And as you can see through the directions, there is a force of attraction between these two charges. Remember, you can pause the video and note down the notes as we continue. Now, this marks our end of line outcome number 1, and I believe we have achieved it. Let's look at line outcome number 2, whereby we are supposed to perform calculations involving charge. And before then, we are supposed to look for the formula that is for charge. And the formula for charge is given by current multiplied by time. We have a power triangle here for charge. Charge is which is abbreviated as capital Q. I is current, abbreviated as capital I, and small t is time, which is abbreviated as small t. Charge is measured in coulombs. Current, we said previously, is the rate flow of electrons and is abbreviated or it's measured in amperes, abbreviated as capital A. The symbol for time is T and it's measured in seconds, abbreviated as small s. Now, we shall be using this power triangle or this charge triangle all through our calculations, so don't forget the formula. So let's look at our example number one. And example number one says that calculate the charge that passes through a lamp in 2 minutes if the current is 1.5 amperes. Calculate the charge that passes through a lamp in 2 minutes if the current is 1.5 amperes. We have seen that time is given in seconds and the question is given as time in minutes. Therefore, the first thing that we're supposed to do is to convert minutes or this time into seconds. Therefore, we know that 1 minute is equivalent to 60 seconds or 60 seconds. What about 2 minutes? 1 minute is equivalent to 60 seconds. What about 2 minutes? So we shall cross multiply, that is 2 multiplied by 60 divided by 1. When you take your calculator and key in 2 multiplied by 60, you will have 120 seconds. Now, we have current as 1.5 amperes and our time as 120 seconds. Now let's determine charge. Remember this part triangle here, we have two lines. We have the horizontal line, this one that I'm trying to indicate with the cursor. This one means division. And we have a vertical line here that is dividing current and time. This line means multiplication. So when we are looking for charge, we can see that charge is above and we have time here and current on this other side. So these two are divided by this line. The one that we have seen is multiplication. Therefore, charge is given by current multiplied by time. Charge is given by current multiplied by time. Therefore, our current is 1.5 amperes and our time is 120 seconds. So when you take your calculator and key in 1.5 multiplied by 120 seconds, we'll get 180 columns. 180 columns. You can write the word columns in full or you abbreviate it by writing capital C. Always remember to write the SI unit as per the question. If the question is asking for charge, remember to write the SI unit for charge. If the question is asking for current, remember to write the SI unit for current. If the question is requiring you to calculate time, also remember to write the SI unit for time, which is seconds. I hope we're together up to that point. Let's look at our example number 2. Remember, you can as well pause the video and try to work on that is on the question at your own speed and make sure you understand. If there's any question, I'll tackle them in the comment section and also when we shall have a meetup in the class. Example number 2. If a total charge of 10 coulombs flows through a circuit in 4 seconds, what is the current? The question says, if a total charge of 10 coulombs flows through a circuit in 4 seconds, what is the current? The question here is asking us to look for current. We have charge as 10 coulombs and we have time as 4 seconds. So current, which is here, high, using our charge triangle, we have current here, down here, we have charge here, and we have time down here. Therefore, when you block current, we'll have Q, which is charge, divided by T, which is time. Therefore, current will be given by charge divided by time. Therefore, our charge is 10 and our time is 4 seconds. So you take your calculator and key in 10 divided by 4 and your answer will be 2.5 amperes. Your answer will be 2.5 amperes. Remember to subscribe in my channel, like and comment. I hope it's clear with you. If I've said if there is any question, kindly inform me through the comment section. And once we shall have a physical class, kindly let me know of any problem or challenges in the video. Let's look at example number 3. And example number 3 is asking us how long will it take for a charge of 15 columns. Let me separate these two. How long will it take for a charge of 15 columns to pass through a wire with a current of 3 amperes? So this question is asking us to calculate for time, and time using the charge triangle, we can see that time will be given by charge divided by current. Our charge is 15 columns and our current is 3 amperes. So we are looking for time. So 15 divided by 3, we shall have our answer as 5 seconds. 15 divided by 3, we shall have our answer as 5 seconds. Remember to follow each and every example that I've given here and work it out in your exercise books. It has been a norm that in my class cannot end without an assignment, and here I have 3 assignments for you so that you may participate and also be engaged. This is not a punishment, but it will enable you to acquire more or understand more about charge. Remember, practice makes perfect. So we have assignment number 1, which says a light bulb operates with a current of 0.5 amperes. How much charge flows through it in 2 hours? Take note, the time is given in hours. Therefore, you are supposed to change hours into seconds. You are supposed to convert hours into seconds and now use your time in seconds and current to get charge. Remember to use the formula correctly. Assignment number 2. If 60 coulombs of charge passes through a conductor in 20 seconds, what is the current in the conductor? Assignment number 3. How much time will it take for 0.2 coulombs of charge to pass through a conductor with a current of 0.5 amperes? Remember to do that assignment in your exercise books. I'll confirm tomorrow in our class. So that is my end of my video. That is the end of my video. Stay blessed and may God continue to empower you in your learning. Thank you.